Welcome to the Deep Dive. And if you're tuning in today, you are the learner in this scenario.
Glad to be here.
So, you don't secure a fortress by only asking the architect what they think.
No, absolutely not. You have to ask the siege engineer.
Exactly. Usually when you're tasked with securing a network, the default approach is just purely defensive. You patch the servers, you update the firewalls.
You enforce two-factor authentication.
Right. You're looking at your digital infrastructure entirely from the perspective of the owner. But our mission today is to completely flip that script.
Because if you're managing a network today, your threat model really needs to assume they're already inside.
Yeah. So instead of just worrying about getting hacked, you're going to learn how to think exactly like a hacker. And to do that, we are pulling from the official Certified Ethical Hacker Curricula by EC Council.
Specifically version 13.
Yes, CEH version 13. This is basically the gold standard framework. It's not just about the theory of cyber threats, but the highly specific mechanical execution of them. We're going to explore the psychology, the playbooks attackers use, and how ethical hackers use those exact same tools to defend our digital lives.
Right, because in a world of, constant information overload and zero-day exploits, relying on automated alerts just isn't enough anymore.
It really isn't.
Understanding the mechanics of these attacks is honestly the only way to genuinely protect yourself or your organization. As the text puts it, to beat a hacker, you need to think like one.
Okay, let's unpack this. Before we understand how to break into a system, we need to know what we're actually protecting.
The blueprint of security.
Right. Anyone in IT knows the classic CIA triad: confidentiality, integrity, and availability.
Yep, the basics.
But this curriculum expands it to 5 core elements. They add authenticity and non-repudiation.
Which is huge.
Yeah. Think of a message like a secure package, right? Confidentiality keeps it sealed.
So nobody else can peek inside.
Exactly. Integrity ensures the contents aren't, swapped out in transit. Availability means the delivery truck actually arrives. But those new two.
What's fascinating here is how authenticity and non-repudiation change the game. Authenticity mathematically proves that the package actually came from who it says it came from.
Not just a forged return address.
Right. And non-repudiation is basically the certified mail receipt. It proves the sender actually sent it. They can't legally or technically deny it later.
So if an attack compromises any of those 5, how does it actually happen?
Well, the text explains that an attack only happens when 3 things perfectly align: motive plus method plus vulnerability.
Okay, wait. Motive, method, vulnerability.
Yes. And the method part is where we see the TTPs.
Tactics, techniques, and procedures.
Exactly. It's highly structured. The tactic is the overarching strategy. The technique is the specific technical method they choose. And the procedure.
It's the systematic approach, right? Like the exact step-by-step script they run to launch the attack.
You got it. It's not just random typing in a dark room.
Okay, but let me push back on that third part. The vulnerability. Aren't vulnerabilities just, software bugs?
Yeah.
Like a flaw in the code?
You would think so, but no. The source lists multiple reasons for vulnerabilities, and software is just one piece of the puzzle.
What else is there?
You have hardware misconfigurations, inherent tech weaknesses, but the biggest ones are human. End-user carelessness.
Right, clicking a bad link.
Exactly. Or even what the text calls intentional end-user acts.
Like an insider threat.
Yeah, like an ex-employee who still has access to shared drives because IT never revoked their privileges.
Oh, wow. So the system is working perfectly, but the human process failed.
Precisely. Which is why understanding the adversary is so critical.
That brings us to the rogues gallery. Profiling the adversary. Because looking at the source material, it proves hackers aren't just guys in hoodies hiding in dark basements.
Not at all. It's a massive structured ecosystem.
So let's run through the classic hats really quick. You've got black hats, which are the malicious ones, the crackers.
The ones breaking in for personal gain or malice.
Right. Then white hats, the defensive security analysts. And gray hats, who are kind of in between. They find flaws without permission, but they might report them instead of exploiting them.
Sure, but the text digs way deeper into the specific classes and, most importantly, the why behind their actions.
The motives.
Right. Take script kiddies, for example. They're mostly driven by the thrill. They lack actual skill, so they're just running pre-made scripts they found online.
Basically just pressing go on someone else's malware.
Exactly. But then you scale way up to state-sponsored hackers and cyber terrorists.
And their motives are totally different.
Completely. They're driven by national security or deep ideological goals. They aren't trying to steal your credit card. They're targeting critical infrastructure. power grids, water supplies.
That is terrifying.
It is. And then you have corporate or industrial spies. They're driven by pure financial gain. They want to steal blueprints, proprietary formulas, marketing plans.
But you know what the most surprising categories to me were?
Which ones?
The suicide hackers.
Oh, yeah.
They're literally like digital kamikazes. They aim to bring down infrastructure for a specific cause, and they have absolutely zero fear of jail time.
Which means standard deterrence just fails. You can't threaten someone who doesn't care about the consequences.
Right. And the other one was red hats. They're like these cybersecurity vigilantes.
The ones who hack back.
Exactly. They use really aggressive attacks to completely destroy black hat operations. It sounds like a movie, honestly.
It does, but it highlights how this whole spectrum of motivations directly dictates the specific TTPs they'll use against your organization. A script kiddie is noisy. A corporate spy is going to be silent and patient.
So if the attackers are this diverse, their methods of attack must be equally varied. Where's the actual front line of this battle?
The text categorizes it into 5 types of security attacks. First, you have passive attacks.
Like eavesdropping.
Yes, eavesdropping and network sniffing. These are incredibly hard to detect because the actual data isn't altered. They're just silently watching the traffic flow.
They're just sitting in the walls listening.
Exactly. Then you have active attacks. These are the loud ones. Denial of service or DOS attacks, deploying malware, SQL injections. They actively disrupt or bypass your systems.
Okay, here's where it gets really interesting.
Yeah.
The third category, close-in attacks.
The physical element.
Right. It gets so physical. Shoulder surfing, where they literally just look over your shoulder at a coffee shop. Dumpster diving for sensitive documents.
Or social engineering a receptionist to get into the server room?
It's crazy that you can bypass $1 million firewall just by holding a heavy box and asking someone to hold the door for you.
It happens all the time, which leads to the fourth category, insider attacks. Trusted employees purposefully misusing their access.
The hardest threat to spot because they already have the keys.
Right. And finally, distribution attacks.
Wait, what's a distribution attack?
This is tampering with hardware or software before it's even installed.
Oh, like a supply chain attack?
Yeah. Yes. Putting a back door into a server's firmware while it's still at the manufacturing plant. By the time you unbox it, you're already compromised.
That is wild.
And the framework scales this up even further to the macro level. Information warfare or infowar.
Infowar. That sounds serious.
It is. Referencing Martin Libicki's categories from the text, it's clear this isn't just about computers anymore. We're talking about psychological warfare.
Like using propaganda or deepfakes?
Exactly. And economic warfare. You don't need to bomb a country's ports anymore. You just block the flow of information to their financial institutions to devastate their economy.
Wow. And intelligence-based warfare, too. Manipulating the data an adversary uses to make decisions.
Right. If you feed them fake radar data, they defeat themselves.
So after mapping out a rather terrifying threat landscape, how do we actually use all this knowledge defensively?
That is where the ethical hacker comes in, the antidote.
Okay, so what exactly defines an ethical hacker in this context? Because they're using the exact same TTPs, right?
The exact same tools and techniques as the malicious hackers, but with one vital, non-negotiable difference. Permission and consent.
Right, because the structure required for this is rigorous. You don't just ask your buddy to try and hack your website.
No. You organize a tiger team.
You sign NDAs. You get a fully signed legal document outlining the rules of engagement before a single keystroke happens.
Exactly. And once they're in, the ethical hacker is trying to answer 3 critical questions for the client.
What's the first one?
First, what can an attacker actually see on the target system? Mapping out the vulnerabilities that automated scanners miss.
Okay, that makes sense. Just getting the lay of the land.
Second, what can an intruder actually do with that information? Can they chain some minor misconfigurations together to get root access?
Seeing the actual impact.
Right. And third, are the attacker's attempts being noticed on the target systems?
Ah, are the silent alarms actually going off?
Precisely. If I can download your entire customer database and your security team doesn't notice for 3 weeks, you have a massive problem.
So if an organization hires an ethical hacker and they fix everything in the report, are they 100% safe afterward?
Not at all. The text has a whole section on the scope and limitations of ethical hacking.
So what's the limitation?
An ethical hacker can only highlight the risks. It's a snapshot in time. It is entirely up to the organization to actually place the right safeguards, train their people, and enforce the policies.
And I guess a new vulnerability could be discovered the very next day.
Exactly. It's never possible to guard systems completely. It's an ongoing process.
And as technology grows at a faster pace, those risks are growing right along with it. How are ethical hackers keeping up with adversaries who are constantly scaling their attacks?
Well, this brings us to the final section of the text, AI-driven ethical hacking.
Right, artificial intelligence. Because cyber threats are leveraging AI tools to automate their attacks now, right?
Exactly. If we connect this to the bigger picture, malicious actors are using machine learning to write polymorphic malware and automate phishing at a massive scale. So, ethical hackers have to adopt AI algorithms and machine learning models just to fight back.
They literally have to fight fire with fire.
They do. And the text outlines 4 massive benefits to doing this. First is efficiency.
Because AI can process vast amounts of data quickly.
Right. It can parse millions of event logs in milliseconds to find anomalies a human would miss. Second is accuracy.
Reducing human error, I assume.
Yes. Machine learning models can analyze vulnerabilities without getting fatigued, which reduces false positives.
Okay. What's the third?
Scalability. Handling growing complexity.
Oh, this is where the Internet of Things comes in, right? The IoT.
Exactly. Think about a corporate network with thousands of smart cameras, thermostats, sensors. Humans can't monitor all of that. But an AI can baseline the normal behavior of every single device and instantly isolate one if it starts acting weird.
That's incredible. And the fourth benefit?
Cost effectiveness. Automating all this threat intelligence and vulnerability scanning reduces the overall operational costs of cybersecurity.
So AI is basically becoming the foundation of both the attack and the defense.
It really is.
Let's summarize this deep dive for you, the learner. By understanding the core elements of security, expanding beyond just the CIA triad to include authenticity and non-repudiation.
And by understanding the motives of the different hacker classes.
Right, and the specific TTPs they use, you are no longer just a passive target. Whether you're protecting your personal laptop or a massive corporate network, you now understand the necessity of thinking like the enemy.
To build a true defense-in-depth strategy.
Exactly. But I want to leave you with a final thought to mull over. We just talked about how both malicious hackers and ethical hackers are rapidly integrating AI to automate their tactics.
It's an arms race.
It really is.
Yeah.
We are entering an era where algorithms will be hacking algorithms at speeds humans cannot even perceive, like literally fractions of a second.
A speed where a human analyst couldn't possibly intervene in time.
Right. So moving forward, as this automation takes over, will the most critical vulnerability in our systems be the hardware, the software, or the human being sitting between them?
Are we just going to become the bottleneck?
Are humans going to become a relic in our own cyber defenses? It's something to think about. Thanks for joining us on this deep dive.
Stay secure up there.